Good morning, and here's our final project coded in JavaScript. So what is our project? Our project is a simulation in which animated colorful blocks move around a box, changing directions when they hit an edge, and briefly changing color when hitting other blocks. Our simulation is on an interactive web browser, and it'll allow the user to choose how many blocks there are in the box, what speed the blocks move at, as well as stopping and restarting the simulation. So here's a demo of the simulation. And as you can see, there are some colorful blocks just moving around, the default being 5 with a speed of 500. And so we can move these numbers up and down, though there is a limit when you surpass 100 blocks, or if you try to enter in a negative number. And here it is. So we have these little alert boxes to the user. And we do this because we want to avoid the program crashing when adding unusual amounts of objects at once. We also randomize the colors when creating new blocks, since we wanted it to be interesting to look at and not just monochrome. Why we chose JavaScript. So we chose this language because its syntax is somewhat similar to the other languages we have learned and programmed with, such as C++ and Java, so it was relatively easy for us to pick up on it. JavaScript is also good for user interfaces, such as the web browser we created, and has a variety of functions which assist with interaction. JavaScript is also good to use for graphics-based projects and works with several different libraries, including Canvas, for example, which is useful for stuff like 2D animations and games. And so here are some minor difficulties that we ran into, most notable being trying to detect the collisions of the boxes and changing the direction of them when they collided. So we worked through this by, as you can see here, this code, creating the blocks as game objects and assigning them X and Y coordinates, and just doing some calculations to find the speed and directions they would go at in order to make the simulation as physically realistic as we could. So our main problem was making our simulation interactive and also deciding which types of files would best help with this. We wanted our simulation to look nice as well as not lag, so our code should be concise and not lengthy and full of bugs. We only had 2 files, our main JavaScript file and our fairly simple HTML, so the program didn't end up being too long and complicated. The UI design was also an important factor, since the browser and its event listeners should be simple for the user to find and click. And this brings us to our key question, which is why JavaScript is well suited to solve our problem, which Alec will now answer.
So why is JavaScript well suited to solve our problem? Let's take a look. One, there's 3 parts of the JavaScript. That's the HTML, the CSS, and the JavaScript. Here, the HTML provides our structure for our websites. We can define items such as buttons, and it links to CSS and JavaScript files. Here's some example of some HTML code. You can give it a name. Here we set the background colors, and we create these inputs which allow us to change the box speed and the amount of boxes we have. It also creates a canvas, which is our little black border that we have, and we can create all sorts of formatting stuff in our HTML file. Now I want to look at CSS. We actually didn't use CSS in this project, but I want to go over it. Instead of CSS, we used the canvas and the inputs right here inside. If you see this canvas, the width 800 and height 400, we did this instead of a CSS file. And we just did that because we felt it was simpler for a smaller project. But I want to go over it because in larger projects, CSS files are very helpful and can be very good to organize stuff. So CSS stands for Cascading Style Sheets. And any styling choice you can think of, anything you want to do is done with the CSS file. And the CSS file allows for a neat layout, and it really controls all the layouts and all your what you see on the screen is controlled by the CSS. So this is some example of a CSS code, and this controls a box A, and it has a height and width of 50 pixels. Its color is red, and its position is absolute. And absolute basically means that it takes on its parent's position. So that's some example of a CSS code. Again, we didn't use it in this project, but I think it was helpful to show you guys. And JavaScript. Finally, JavaScript is used to modify the contents of the website and pretty much does all the heavy lifting and allows for user interaction. Anything you can think of JavaScript, you can pretty much code in JavaScript, such as passwords, creation of games like what we did, and special effects on websites. And you can define what the button's behavior is and what the input behavior, and if a user clicks something, this is where you define it. So I want to take a look at some JavaScript code. Here's our game loop function. Basically, what this does is we just loop through this game function over and over again. And as you can see, it's kind of similar to stuff we've seen before. Let is how we set variable names. We have if statements with the curly braces are the same. What's special is we can do this alert button, and as you can see, we have whoa, too many boxes as our alert. You have for loops, and the let allows variables to be defined. You don't have to say string or int or anything like that. Let just figures it out for you, which is super nice. Yeah, and so I will go back to the slides. And so how do we solve a problem? The HTML file allowed us to create our buttons, our on-clicks, and link everything together, such as our JavaScript file and normally a CSS file. It allowed us to have the inputs that allowed us to change the speed and how many boxes there were. The CSS allowed us to style our simulation. Again, we didn't use the CSS, but normally you would. So, and finally, the JavaScript allowed us to create the rest of the simulation. So the JavaScript allowed us to do all the heavy lifting and give us the product you see on your screen.